Push record.
Cool.
Minimize that. Let's see what we got here.
Okay.
Name one of each. Let's see. Looks like somebody's answered all of these.
Uh-huh.
You've done that?
I have, yeah.
Well, let me review it.
Sure.
AB is a tangent line. CD is a secant line. The difference between a secant line and a chord is a chord does not extend beyond the circumference.
Okay, so like CG would be...
A secant line does. In other words,
so
if you extend CD, you have a secant line.
Okay.
But notice that CD is also a chord. If you go precisely from C to D, that's called a chord.
Okay.
Minor arc, that's an arc less than 180 degrees.
Cool.
FH is such an arc, okay. Semicircle, arc EF. Now, there is one problem with only using two letters.
Uh-huh.
Let me show you what that problem is.
Sure.
I have point A, B, and C.
Okay.
And I say arc AC. That's fine. You know it's that arc right there.
Right. Yeah.
It's not this arc here. Even though if B wasn't there, I mean, let's remove B for a moment. Now if I said AC, you don't know which way to go, right?
Right.
You're always going to choose the the smaller one. The one that's less than 180 degrees. But if I have a point over there called B, now if I want to define this arc, I call it ABC.
Okay.
As opposed to AC. AC
Okay.
definitely defines that arc only because this arc would be called ABC.
Okay.
So in the problem over here, where it's saying the semicircle, let's use as many of the letters as we need to define which semicircle, because there's actually two of them. I could go, I know that EF is a diameter, so anything, in other words, when you say EF, that's kind of correct, but are you referring to the left part or the right part? And we don't know.
Okay.
So if you want to be descriptive about which half you're referring to, what would it be?
EBF.
How about EBHF?
Just CBHF. Okay.
EBF would actually be descriptive, but I would be inclined to put all the letters that come between E and F. So I would call it EBHF. I guess EBF might be enough because EBF distinguishes it from the other way, which I suppose you could say EDF or even EGF.
Right.
There's so many points on the circle, I'm not quite sure what the convention is. But when there's only 2 points on the circle, or rather 3, the one I drew, then it's really important to use the third letter.
Okay.
In other words, if I say AC, I'm definitely referring to that arc. If I want to refer to this arc, I have to call it ABC or CBA.
Okay.
Okay.
Cool.
Okay. Chord, CD, is also a chord as well as the secant line. Inscribed angle. You said angle C.
I was kind of confused.
Okay, well, let me tell you what an inscribed angle is. Something looks like that.
Oh, I see.
What we're talking about is an angle whose vertex is on the circumference.
Okay.
Okay?
Okay.
And in this case, we may have to describe it with 3 letters, not 1.
Right.
Trying to see, I do not see any angle on that diagram that can be described with just 1 letter.
No.
So tell me what 3-letter angle is an inscribed angle.
Yeah. MFH.
No,
Oh, that'd be an
the
inscribed.
vertex is not on the circumference. The vertex is at the center.
So would it be CDG then?
There
Because
you
it's
There you
okay.
go. The vertex of CDG is on the circumference.
Okay, that
That's
makes
what you need. With both rays of the angle intersecting with the circumference. In other words, I'm not sure that this would necessarily count as an inscribed angle.
right.
It has to go all the way. Well, hold on. I didn't mean to do that. I meant to do this.
No, you're fine.
When it gets late, I'm stupid, so.
No,
That
we
is,
all are.
that is not an inscribed angle. It has to
Okay.
go all the way to there.
Mm-hmm.
So, how did you describe that angle again?
CDG.
No. You need to make the vertex the middle. So,
Okay.
angle DCG
DC.
or angle GCD.
Okay.
Okay, you don't want to start it with the vertex.
Okay.
Because actually, when you said CDG,
Uh-huh.
you're referring to an angle like that one right there.
Mm-hmm. Okay, that makes sense.
In other words, the terminology for angles is very precise.
Yeah.
And the only letter you can't start with is the vertex.
Okay.
Okay?
Okay.
Central angle, EMH. That's correct. Notice the middle letter is the vertex of that angle. You started at one end. Central angle is, what's another central angle?
Another central angle would be FME.
FMH?
Mm-hmm.
Is that what you said, or FME?
FME.
That actually is also a central angle, but
Cool.
it's a 180-degree central angle.
Yeah.
So, in other words, that's not generally what you think of when you are looking at central angles. In other words, if that's A, B, C, indeed, there's an angle there, and it's 180 degrees, but that's kind of not what you think about when you think about central angles. You think about angles like this.
Okay.
Okay?
Okay.
So what's another central angle there?
HME would be one.
Yep. Also HMF.
And F, yeah.
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 But EMF was also a central angle. It's just a 180-degree one.
Okay.
And the diameter?
Mm-hmm. The diameter, yeah. EF.
Yeah, that's correct.
Cool.
Let's look at the others here.
Sure.
I suppose you, oh, there it went. It disappeared. I was going to ask you, do you know how to make that picture disappear?
No, you're fine.
Angle BCE. Okay, that's correct. It's half. Angle, in other words, an inscribed angle is always half of the arc that it intercepts.
Right.
Okay? Angle
Cool.
BDC. Well, if angle C, see, this is one case where you can call that angle C.
Okay.
In
Yeah.
other words, the correct mathematical terminology is BCE, but as long as it's the only letter, nobody can misinterpret if you call it angle C.
Right.
I could not call angle A as nothing. And angle B is made of two angles, so I wouldn't ever say angle B. But
Okay.
that's the only angle I could describe with just one letter.
Okay.
Okay? And
Yeah.
if that's 30, what kind of triangle is where I'm pointing?
Is that an isosceles?
Correct? Which means
Cool.
what about angle
Uh,
CBD?
the two sides are congruent to each other.
Which means their angles are what?
30 degrees each.
Correct. In other words, it's not, an isosceles doesn't just mean the sides are equal, it means their opposite angles are equal.
Uh-huh.
And we just figured out that that was 30, so that has to be 30, which makes that 120 because the three angles have to total 180.
Right.
Okay.
Cool.
E, B, C. E, B, C. There isn't an angle there. Oh, the measurement of arc EBC.
Oh, arc EBC, yeah.
EBC, yeah, the measurement of arc EBC. Yeah, I guess I was wrong. They didn't put the A in it. In other words, three letters were all they needed to designate that arc.
Right.
What's the size of that arc?
Um,
What's the size of the central angle that creates that arc?
central angle that creates the arc.
The only reason I asked that question is because you're the only one that's ever given me the diameter as a central angle.
Okay.
Which is correct, but very few people do it. So if the diameter is 180 degree central angle, what's the measurement of that arc?
Then it'd have to be 90, right?
Have to be 180.
Oh, just 180. Okay.
Central angles always intercept an arc that's the same size. In other words, in my drawing over here, if that's 120 degrees, then that's 120 degrees from there to there.
Okay.
It's only inscribed angles that intercept an arc that's twice their size. That would have to be 60. So you only really have two angles. You have a central angle, which is equal to the arc, and you have an inscribed angle, which is half the arc.
Okay.
Okay? So the measurement of EBC, and they're not talking about that angle,
No.
they're talking about that arc, has to be 180.
180. Okay.
Yeah, because that's a diameter. If what is that? Oh, if CDE is a diameter, then that's a semicircle.
Right.
Half of the circle is 180 degrees.
Okay.
Angle BDE. This is this angle right there.
BDE.
Sorry, it's
have to
that
be 30,
angle.
right?
We already figured out this angle right there, right?
Yep.
Angle
we saw that was
BDE.
120.
120 was correct. Well, what is true about that angle and that
angle? They're linear.
Correct, which means they're what? What's the word? Supplementary.
Yeah, supplementary to each other.
Supplementary means what?
180.
They add to 180.
Yeah.
So what does it have to be? If BDC is 120, then this one has to be what?
So that would have to be, so 180 minus 120.
Correct.
Which is 60.
Right. And notice that that's a 60 degree arc that it is intercepting also. So there's two ways to figure out this angle. Immediately, we should know it's 60 because it's
Mhm.
a central angle and it's intercepting a 60-degree arc.
Right.
Okay? But you figured it out the other way, which was, first of all, figuring out this angle, which is 120, and that's linear with that angle, so it has to be 60. So this
Mhm.
answer needs to say 60.
Okay. Cool.
Okay? And finally, D, B, C. D, B, C. Didn't we figure this one out already? We figured
I
out.
thought we.
Yeah, that's the
Yeah, we
same
did
as
BDC. Yeah,
BCE.
DBC.
So
Yeah,
it's
120.
30. No, it's 30 is correct.
Oh, 30 is correct. Okay.
Yeah, D,
Yeah.
B, C. Always know
Okay.
that the vertex of that angle is the middle letter.
Uh-huh.
Okay? Well, if you look at that angle, that's very acute.
Right.
Definitely less than 90. And
Mhm.
it looks like it's less than 45 even. So 30
Yeah.
is a reasonable answer. If you got something like 120, always look at it to see if it makes sense.
Yeah,
If you
120
got
doesn't make sense.
120, that doesn't make any sense for that angle.
No.
Not that that's what you wrote. You wrote the correct answer. But
Yeah.
all right, let's see. We got another few minutes.
Cool.
Let's have a look at this.
Mhm.
All right, there's a couple of key things you're going to have to memorize,
Mhm.
and this is one of them.
Okay.
Okay? And here's what the theorem says. That if you
Mhm.
take a circle, and you take a point outside the circle, and you draw two tangent lines,
Mhm.
one there and one there, two things happen.
Mhm.
First of all, they're equal to one another, always.
Right.
Second of all, angle 1 is 1/2 the difference in the two arcs.
Okay.
Let me label this. A, B, C. So it's the bigger arc minus the smaller arc.
Mhm.
Bigger arc is ABC. The smaller arc is just AC.
Okay.
Okay? So that's what angle 1 is always equal to. Is
Mhm.
1/2 of the difference of the two arcs that get intercepted here. These two
Okay.
tangent lines are always going to give you that arc
Mhm.
and this arc.
Okay.
And usually the red one is the bigger one.
Mhm.
In fact, I think it always is. I don't think, yeah, it is. You cannot create this drawing without making ABC bigger than AC.
Right.
But it's the difference and half of the difference.
Okay.
So in this drawing, what do they give us? They give us 70 degrees is ANT. So they connect those. So they're saying that's 70 degrees. Okay?
Mhm. Okay.
Well, since this is an isosceles triangle, what's this angle over here?
So if that's an isosceles, so that also have to be 70.
What's angle 1?
So 180 minus 140, so just be 40. Cool.
And find x. Okay, we solved for x.
Awesome.
But it's 40, not 30.
Yeah.
Unless I'm missing something here. Angle ANT, which is this angle right here, is 70, which means
Mhm.
that's 70. So that has to be 40. Yeah.
Yeah. That sounds
Oh,
right.
that's what it says. Okay. What was I seeing? Oh, I was looking at your drawing over here that said 30.
Oh, okay.
I didn't see this answer. I was just looking over there.
Mm-hmm.
All right.
Cool.
Dylan, I am going to let you go. I'm
Sure.
sure you're tired and in need of sleep.
Definitely.
Get as much sleep as you can. It's hard to function as a proper human being without sleep, whether you're
For sure.
playing baseball or doing math.
Exactly. All right.
Uh,
Well, thank you, Mr. Count. I
I
appreciate
think you
it.
have a session for Sunday, so I'll talk to you then.
Sounds good. I'll see you then.
All right, bye-bye.
All right. Thanks, Mr. Count. Bye-bye.